Hey guys, what's up? Eddie Aho here with KissAnalog.com. We're going to continue on with this video. I did a box opening. If you didn't see that, if you'd like to see that, I showed you how these guys look coming out of the box, kind of showed you what the back, front, sides, and everything look like. In this video, I'm going to show you some waveforms. So let's just jump into it. Hope you like it. All right, guys. So in this video, we have the Uni-T 962E, 60 megahertz. We have the UTG 4082, and this is 80 megahertz, two channel, 4-channel, and this guy is the UTG 9504T. And then I'll also show you the UTG 1042X that's sitting right here, okay? And we're going to use the UPO 1204 Uni-T oscilloscope to look at some waveforms. So let's do it. All right, guys, so here's the little guy. Here, let me just hit the switch right here. There's your inputs, your power, your USB, and your on-off switch. So on this side, you have your channel 1, channel 2, and your FSK sync output, okay? That's your frequency keying. All right, so I'm going to hit the on-off button and watch it boot up. It comes up pretty fast, I think, right? Yep, it's up. So we got channel 1 on this side of the screen, channel 2 on this side. It says high Z off and high Z off, okay? Here, let's just talk about that for a moment. Well, actually, you know what? This thing looks like it's set for frequency. This one's showing that it's sine wave. All right, so if I go to wave, it shows me the different waveforms, and I can say, okay, yeah, I want to be sine wave. Okay, so I just push this in, click on that, and then I can say, oh, what's the frequency? I can use this dial to change it, or I can push this button in, go down to amplitude, change that. But so if I'm here, I just push in, highlights the number, and I can go up, okay? Or I can come over here and say, I want to go frequency of 1K. So I push 1, and then I got microhertz, millihertz, kilohertz, meg. So I just say kilohertz. All right, so then amplitude, I can hit that. Or I can do, like I showed you before, I can push this down so nothing's highlighted. And then when I go like that, it highlights the number 1, that's frequency. But if I push it again, come down here, amplitude. So there's different ways to do the same thing. So I can go, it looks like it's maxed out, 7 volts RMS, right? And then let's go back there. The other way, I can just start pushing in any number here. Let's say I'm going to go 20 volts peak voltage, or peak, okay? So we got millivolts peak, volts peak, millivolts RMS, and then our volts RMS. So let's just say I'm going to choose volts RMS. It's too high, right? So then I just push any button, and then it maxes it out, okay? So 7 volts RMS is the max. All right, and then offset, I can put a DC offset there, and I can just start pushing any number. Let's say if I want to say 9 volts, millivolts and volts, and it gives me 9 volts offset, okay? And it shows you what it looks like here. So now my sine wave is going to be up here, okay? But I don't see anything on the scope because the output's off right here. So that's, I can push this button right here and it turns it on. And there's my waveform. I can bring my trigger up. Okay, so I get my trigger there, and the voltage, it says it's 9.18 or 19 volts, I guess. And peak to peak is, what is that, 22 volts? It's hard. Oh, it's 2.2 volts. I think it's just this ripple. So yeah, the amplitude says it's 0.7, so it's like 1 volt amplitude RMS, okay? So when I did that 9 volts offset, it changed my amplitude automatically for me. So, and I can see it there on the scope. I could bring this down so I could, you know, get a little better use of the screen on my scope. And then I can bring the trigger down just to top the waveform to capture it. And if I get the cursors up here, and right now it's on time, let's go to voltage here. And then I can put this at, I don't know, around the top of the waveform, click on the next one, bring it up. So there we go. So my cursors are saying A's, there's 16 or 10.24 volts, and this 7.92, so it's 2.3 volts peak to peak. So it should be like 2 volts peak to peak, I believe. It's just that, you know, if I get my cursors right on the line, yeah, it's closer to 2.2 volts. So, you know, but yeah, and then, you know, if you really wanted to look at this, you could AC couple and just look at the waveform. So now I'm kind of talking about how to use a scope. But yeah, so that's how this guy works, right? So for channel 2, I can just come down here and hit this button, and it highlights this. So if I go back to channel 1, it highlights that. Channel 2, it highlights this. So now I'm ready to do the same kind of setup on channel 2. And then I can hit the on button to actually put it out of the BNC connector here, okay? So that's how you can do your 2 channels. That's your sine, your square. So let's go back to channel 1, okay? I'm going to just go to offset and put 0 volts offset. I'll go 0 volts, 0 millivolts offset. So it's really low. Now center that screen, and then for amplitude, I'm going to say, I'm going to act like I don't know what it is. I'm going to say I'm going to want 50 volts peak to peak. Out of range. So, oh, okay. And it says 20 volts peak to peak. Good. I do 20 volts peak to peak. So there's my screen. Here, I'll turn off the cursors. 6.94 volts, 20 volts peak to peak. It was kind of bouncing around between 19.8 and 20 volts. So yeah, it doesn't, okay, let me get more waveforms to see if it really is okay, there's 20 volts. So with this, and it kind of bounces between 19.8 and 20 volts. So you have to get more waveforms sometimes to get a better math readout. So the scope has enough cycles to get the math. But here, let's just, so that we can see waveforms, I'm going to spread it out like that, okay? Okay, let's go to waveforms and go to square. I'm just kind of showing you how this display works. Okay, there's square. Okay, let's go back to waveform. Let's do pulse. Now, with pulse, I need to change my duty cycle. Right now it's 50%. That's why it looked just like a square wave. So with the pulse, you can change it to like something like that. Or I could just say 5%. Now you notice that when I hit a number, it comes up with different options. So that's kind of nice that you have this default, because maybe I want to go 95. So, you know, 95% time it's on, 5% it's off. So that's pretty neat how you can do that kind of stuff. Let's go back to wave, and we got ramp. Okay, same thing with duty, symmetry, same thing as kind of duty cycle. I can hit any number and it'll come up with stuff. I'll say 25. So then that's how you get your sawtooth. So, okay, let's go back to wave and arbitrary waveforms. Wave file. It says wave file internal is 0. External is 1. Okay, so let's go back. Yeah, it doesn't look like there's any waveforms saved. I was going to try to cycle through some. So once I'm there, I could hit this and then cycle through, but it doesn't look like we have any others saved right now. So let me go back to waveform. Page down, I get noise. Okay, that's just white noise basically. And you can do an offset on that as well. And you have DC, so you can just do a DC waveform and yeah, see, whoops. I hit the button while I was scrolling up. So it looks like 10 volts is the max of DC offset I can do. So go back to wave. Let's go back to sine wave. Okay, had that DC offset, so it kept the DC. So let's go back to wave, sine, and let's turn it on. And there we go. So, so that, yeah, that gives you an idea how this thing works. Now, there's the mod button, and that's modulation. So you can see we're modulating this kind of wave. It gets more cycles, you can see that. So that's what that modulation, it says depth is 100%, meaning it comes all the way down to 100%. So if I come down to depth, and if I start to punch in a number, it's going to give me the same kind of stuff. Let's say 25%. Whoops. Okay, so I hit 25, or I can hit 95, and it almost comes down to 0. So yeah, so that's how you kind of mess around with that. Modulation frequency right now, it's 100 hertz. So if I go to 200 hertz, 3, 4, so I got the 1 kilohertz, right? And so if I do 1 and 1, it's going to look really weird. So it's modulated at 1 kilohertz, plus it's a 1 kilohertz sine wave. So that looks really weird, right? So if I go back to my sine wave, and if I go frequency and go 10K, I go 10K like that. Now it's 10 kilohertz sine wave, high frequency, but it's modulated at 1 kilohertz. Bring the trigger right down there so you can see it. Okay, so 10K, and basically we should have about 10 bursts in between, and then between every 1 kilohertz. So yeah, that's the modulation. Now if I go back to mod, it says sine, right? So that's amplitude modulation, right? We're modulating the amplitude. You can do frequency modulation. And so you should see high frequencies, low frequencies. It's all mixed in there, see? It's going high and then low. And, oh, that's phase modulation. Frequency and phase look very similar, right? So FSK, that's where you're going to have some high frequencies, low frequencies, and probably not set up right. Oh, because it's at 10K, same as my frequency. That's why. So if I go back to wave and frequency, 1K. Okay, now we can see the FSK. So, because it's at 10, it's starting at 1K and 10K. So high frequencies would be a 1. So if I just freeze that, so that's a 1, that's a 0, that's a 1, that's a 0. So that's what FSK is. See the 1s and 0s? I freeze it. So that's frequency keying. And then there's other ones too. But on this one, we just have the FSK. So here, let me get this going again. Let's see what line is. So line, well, I think that means linear. So you're going to start at one frequency and stop at the other frequency, and you're going to do that in 100 milliseconds, the whole sweep time. So you can kind of see high frequency, low frequency in 1 millisecond time frames. So if I start to zoom out, you're going to kind of see it takes. Yeah, so anyway, there you go. There's modulation, linear modulation. That's kind of one of the older ones. And then there's log. So it's going to do the same thing, except for it's going to do it logarithmically. So yeah, you can see the difference, right? It's going to start off slow and then go fast, slow and then fast. That's logarithmic. So slow and then fast. Okay. And then what else we have? Okay, and that's it. There's no more pages. So 1, 2, 3, 4, 5, 6 different ones. Okay, so that's pretty good. That's pretty excellent, actually. 60 megahertz frequency on this thing. That's a sine wave. The square wave is usually going to be a half to fourth of that. So probably down to 10 or 20K. You have to look at the spec sheet and look at the max frequency for all those different waveforms, because they're going to be different. Okay, so for a lower cost unit like that, they're going to be a little bit more different. Maybe a higher cost one, maybe it's only half as much, but one like this might be a third or a fourth of the max frequency. Okay, all right guys, so this is a 1042 And this is the one we're just looking at. Look at that. The screen size is the same. Pretty cool, huh? But what are the differences? Well, we have 2 channels right here. You turn them on this way. So it's very similar to this one. Menus are it's all very similar, right? So let me look at this. Mod wave utility, the keypad, the arrows. I mean, very, very similar operation, right? We got the USB port on front, the power button on front, and then we have our 6 buttons, 1, 2, 3, 4, 5, 6. So pretty much the same, right? Okay, now let's take a closer look. All right, guys, so we have the sine, square, pulse, ramp, arbitrary, and we have a page down. Let's look at the arbitrary waveform. Okay, let's go up here. And it says 0 and 1, so it's the same. So far, everything's the same, right? Here's, you can toggle through with these arrows. So, okay, we're going to cancel that. So let's go back to waveforms, page down. Noise and DC. So all that's the same, right? Now let's go to the modes. So modulation, right? So now we have these things. This is a little different. Now we have all the modulation stuff, but then we have a sweep and a burst. So let's go to modulation, AM, FM, all the same stuff, page down. So here's a FSK. But we have a PSK and a PWM and then a return. So ASK, PSK, yeah, or FSK. So very similar, right? But we have a couple extras. All right, so let's go back to mod. And let's go sweep. Now here's your linear, your log. So you have the ASK and the FSK. But now you have your linear log on this page. So you have several more ways to sweep, right? And they just put the old-fashioned ones all by themselves, the log and linear. Let's go to return, sweep. So, okay, so then we also have a burst, though. So then you can have this kind of cycle. You can have infinite, where it just continues. And there's a gated. So I think the gated, well, I'm not going to get into all the different ones. We just have to look at them for now, okay? So you can see there's more options with this one, okay? We're going to talk about some of the other differences between these, but as far as functionality, you do have more modulation types, right? And as far as the arbitrary waveforms, the memory depth and the resolution. So some of that stuff, we're going to talk about those kind of differences when we talk about each one, okay? Because we'll go down the list. But you know what? There is something I forgot to show you that is common on both of these, is you have utilities, okay? Your output's off. That's what these are. Your inversion, your sync, high Z, and your amplitude limit. So you can set your amplitude limit so that you don't get the full capability of the device. Maybe you don't want to go above 5 volts or something. Maybe you don't want to go above 1 volt because you could damage something. So you can set your amplitude limits. So you also have this load Z, and that's the thing I kind of wanted to show you. So, and you can come across here and hit there too. And then here's your upper and lower limits. Let's just go back. So here's your load, okay? Now, when you hit your load, you see this? You got ohms, 50 ohms, 75, or high Z. So we're just normally set up for high Z for like scope probes and if you're going to input of op amps, things like that. But if you are doing a lower impedance thing, then you have options and you can start plugging it in. You can start saying, I think it's 4. Nope, I want to choose 50. And it goes 50 ohm. Or you can go, oh, wait, hold on. I want to go to 6. Oh, wait, no, 75. Or you can say, you know what? Actually, it's something in between. And you can go 6 ohms. So you can dial in any number you want. But there are some pre-programmed, common things you might want to use, okay? And this guy's going to have the same kind of setup, okay? You're going to have utility, and it's the same thing, okay? So if we come down to high Z and start plugging in a number, same thing, okay? All right, let's look at the 4082. All right, guys, let's make sure the power's on back there. I think it is. All right. Hear the fan kicking on. Listen to that for a moment. It's louder than the scope right behind it, the Uni-T scope, UPO 1204. This is an awesome scope, by the way. Okay, it's taking a moment to power up. This is the first time I've powered it up. Now, I have hooked up a probe, by the way, just like the other generator. So we'll just go through the menus real quick just so I can show you the difference what they have, okay? All right, look at that. I like it because if you're used to using one or maybe you have two of their generators, they're set up very similarly, which I think's I like this setup. It's pretty smart. USB in front. We have this, is that an RS-232? Looks like it's designed for a shielded connection too. It has the little jacks here on the side. All right, so let's take a look at this. This is two channels. You got your channel 1 here, channel 2 here. Now I'm plugged in channel 1, channel 2. Okay, now you highlight channel 2 there, highlight channel 1, just like the other one. But this one, we do have a little bit more information, right? Okay, this one, the information is laid out a little bit different than the other one. We have the frequency, amplitude, offset, and phase. And then up here it says high Z, it's off, and it says what waveform we have on. So there you go. It's all looking very similar, right? Okay, then over here, if you look at this panel, we have modulation, sweep, and burst. So that's kind of those three options on the 1042 that I showed you, okay? So let's look at modulation. Okay, right here says we have frequency, AM. So if I push this button, wow, look at all those. It is crazy. AM, FM, PM, ASK, FSK, which the 1042 had, right? But then it also has this BPSK, QPSK, OSK, QAM, PWM, and sum. So I think the sum is a really neat one. You can sum the two different, you can modulate this one based on this one. So I think that's pretty cool modulation. And you got source internal or waveform, wave file. And look, let's look at our sine wave, square wave. So here, let's turn on the channel on the output, as a matter of fact. Okay, let's go set this guy up, first of all. Let's turn off the... Okay, so you hit the modulation a couple times and it turns off the... See, one time selects it, another time just gets rid of it. So let's go set up our frequencies. Let's do 1K. And look at this, it gives you this range, but then also, so it tells you your range right there, which is neat, but also you can just say, oh, I want 1 kilohertz. Okay, so then amplitude, let's do 50 volts. Let's see if it'll let us. Values out of range. So what it choose for is 20 volts peak to peak. And then you have your whoops. And here we are on the screen, by the way, if you haven't noticed that yet. So then I can come down here to offset, same thing. I can change the phase and see if I change the phase, say 45, instead of starting here, it'd start here. Let's see if that works out. 45. Oh, look, I got presets. So I can go 90. So instead of starting at the bottom, it started at the top, but I could go 45 too. I thought when I punched it in, I could just hit this as the enter. Do you see the enter key? I don't see enter. That's return. That's not going to do it. And wow, okay. Sorry guys. But if you go here and select it, you can go 40 And then you can use this arrow to get you over to the next digit. I can go 45.5 if I wanted to, or I go 45.555. So yeah, so that's how you set up that kind of stuff. If I just push any number, I can go right back to 0 again. All right, so back to 0. Okay, so that's all your outputs. That's your frequencies. Lots of frequencies. Lots of. Let's look at the modulations again. I mean, lots of modulation types, right? But I also have the sweep one. So I have linear and log, right? Just like before. And you can set up your start, stop, and, you know, all that kind of stuff. So really nice display. Get some, you know, a lot of information there. And then, so modulation is sweep, and then here's burst. So you can go back to burst. And very similar to 1042 up above. I mean, you can see how each one is just giving you more and more features, though. Okay, so what else do we have on this one? Here, let's go to channel 2, okay? I want to set this guy up. So let's go to channel 2, and then we'll... Okay, I got to get off of burst. Okay, so channel 2. Okay, so let's go to channel 2 and set that up for, like, say, 40K. Okay, 40 kilohertz. And I'll go to channel 1. I want to get that off of the burst thing too, because last time when I was playing around with those, it saved them. So I just want to get rid of that. So we got 1K, 40K, 20 volts peak to peak. And let's go to amplitude on channel 2. Let's just change that to 5 volts. Let's go 5 volts peak to peak. Okay. All right, guys. So I got to read about this one. Channel 1, channel 2. It almost looks like it swaps them, but yeah, so I'm not sure. I don't know what's going on right there, guys. Sorry about that. So you got sine, square. I mean, look how they just assign all the buttons so you don't have to go through the menu like I was doing before. DC, harmonic. Oh, yeah, and also you have the harmonic one here. That's really cool. The arbitrary and the noise. So yeah, you can set up your even auto harmonics right here, or you can go to all. So it's really cool, all the features you have here. I should turn off channel 1. Let's go channel 1. Okay, let's try channel 1 here, and see, it shows our harmonics right here. That's pretty cool, right? And the order, like, you know, what's the order of frequencies? That's pretty, I mean, really neat stuff. So 16 orders. And if I come down here and say all, and there's a user setting too. So here's the order. So third order. So yeah, you have the, you know, so the harmonic thing's a really cool feature. That's something I haven't used before, so I'd have to learn how to use that guy. But you know, you got your number pad, same as the other ones, but you just have these quick selection buttons. And, you know, up here, okay, what's this setup? So you have user setup, digital. Okay. There's a UART. Okay, that's your connections. Oops, let's turn that off. And then let's go to counter. So, of course, one thing I always forget to mention, but these generators are also counters. So if you just want to use them as counters, they're, you know, they have really nice resolution. I'll read off the numbers when I compare all of them at the end, okay? But yeah, so you can use them as counters. So, okay, so I'm going to turn off the counter for now. So, yeah, it's just got these quick access buttons. Let's go to user setup, and here's your, okay, so absolute sine, arbitrary sine wave. I guess that's what that is. So right now, I'm not sure. It looks like these are just all set up by default, I think. So you can set up your waveforms and do all that kind of stuff here. Okay, then over here on the far right, we have our preset. So whether to restore the factory settings. I think it is set factory settings storage. Okay, so it looks like you do have internal storage, right? So you can set up your different types of files that you want to store. You can load files. Wow, that's a cool file. Look at that. So that's the arbitrary select runt waveform. That's a neat waveform. Let's see what it looks like up here. I'll freeze it. Yeah, look at that. Isn't that cool? So that's a interesting waveform somebody set up. So you do have these waveforms that someone has programmed. Let's see, so that's the runt waveform. So what else do we have? We have a Windows, whatever that is. Let's set that one up. Let's load that. Okay. Okay, here's your built-in. Wow, look at all these. Gaussian. Wow, negative ramp. So this thing has quite a few built in. And look, you got 2 pages too. Wow, that's interesting. So yeah, a lot of built-in waveforms. I mean, really neat. Here's the utility system, high Z, so it tells you the setup here. Backlights looks like it's 100%. Screensaver's off. I'll bet you this isn't factory, because factory probably wouldn't have 100%, but yeah, so that's pretty interesting. Channel 1 config 2, system IO, user settings, LAN, and then we have a help menu. Okay, let's come back to here. Let's get out of this. All right, so we're out of here. Let me hit the help. Okay. Press the help key to open or close the help menu. All right. So anything you select on here, it's gonna, so this is your help menu. Once you've activated it, you just kind of toggle through. So if you had a certain window open and you wanted some help on that, okay, let's see if I have the harmonic one. So the allowed maximum number of harmonic outputs, the parameter types, phase. So yeah, so you just move your arrows around to select which window you want help with, and that's pretty cool, right? All right, guys, now we have the 9504T, Uni-T 9504T. Man, this is a beast, right? This is a big boy. Let's turn that on. There's a hard switch in the back I turned on already. And we'll see what it looks like. Yeah, these things all boot up fairly quick, right? You know, I would say the fan on this one, I'd have to power up the 4082 again, but here, I'll be quiet for just a sec to listen to the fan. Okay, so yeah, this seems quiet in this unit. Okay, there we go. Wow. Okay, now it's 4 channels. So instead of, I guess they decided instead of showing you 4 broken up channels, they just show you the expanded window for each channel. So if I hit channel 2, yep, look at that. That's pretty neat. I like the colors too, actually. Okay, so we go to channel 1. And you know what? Let's just go to channel. Oh, you know what, guys? By the way, I'm going to talk about some of the specs on these things at the end, okay? So there is a difference between channel 1 and 2 and 3 and 4, okay? So look at this. We got all these waveforms, and check it out, guys. Touchscreen. So you can select your waveforms. Wow, look at that. Holy cow. Oh my heck, look at this. This thing has a ton of waveforms built into it. So look at that waveform. Whoops, I got the scope turned off. Here, let's turn on the output. Okay, I'm going to hit the auto set on this guy up here. It's a pretty complex waveform. So yeah, look at that. Pretty complex. You guys in the automotive industry probably understand that. It's ISO 16750-2 starting. So is that each cylinder firing? I don't know. I don't know what the waveform this is. I just pulled one up. But yeah, look at that. And Uni-T scope captures it just fine. Pretty cool. All right, so man, this thing, you can see the power in this. So the arbitrary waveforms, tons of them, right? Okay, and then it looks like, do I have them all on the screen? I think so. Okay, I think I'm getting oh, this is CW. Okay. So there's the modulation. Yeah, look at that. That's interesting. So I'm getting a modulated AM modulated waveform up there, and it's in burst. Let's go back to sine or square, and I can turn off these. I think let's see, how do I turn that guy off? It's continuous wave, it says, right? Okay, check it out. It has a copy. It says channel 2 to channel 1. Man, this thing is just loaded with waveforms and different things. All right, guys, so continuous wave, I guess that's just, the normal function, right? So your normal function, continuous wave, frequency, we can go 40K maybe. We can go 40 megahertz too. Okay, so then we can say amplitude 5 volts. We could go, let's try to go 10 volts peak. Okay, offset, phase. Look at this noise sum. Wow, that is crazy. Whoops, that's phase. Noise sum on. Let's turn it off. That's interesting. Signal to noise ratio 10 dB. So that's kind of noisy. So you can simulate a noisy waveform. Isn't that wild? Man, what if I say 1 dB? Oh, out of range, 1.7. So that's a noisy waveform. Look at that. It's kind of crazy, man. Wow, I haven't had a generator this nice, I guess. So let's just turn it off. And look, back to a nice clean waveform up here. Man, this is super cool. So you got all these things, arbitrary waveform. Okay, this is WARB. I'm not sure. I don't know what that is actually. Function not available. So maybe that's something you have to buy. Then arbitrary waveforms. It's set for DDS right now. Wow, this is crazy. All the different features this thing has. This is a wave file. So again, we're back to this thing. Man, look at this thing. Engine. I don't know. Let's go to this guy. Whatever that is. Let's load that thing up. Okay, so it's some kind of pulse width kind of waveform. Now we're at a high frequency now. I don't know if that's applicable to this. So 10K. And look at that. I probably should go through some kind of channel to see if I can decode that, right? So, but wow, just tons of things, guys. Modulation. Look at all the different kinds of modulations. Just all kinds. And it's neat that it kind of shows you what they kind of look like, right? So really neat. Man, this is crazy. Sweep, linear, log, step, and list. You can list things and say, I want to modulate my waveform this way. So you can really get a waveform exactly what you want. And here's your burst. So, man, just tons of waveforms, guys. This is crazy. If I go harmonic, sorry, unable to burst. Oh, okay, you can't do burst and harmonics. Let's just go to continuous waves, go to harmonic, and again, you get this harmonic file. So, yeah, I'd have to spend some time to set that up and see how that works exactly. Here's your high Z, 50 ohm. So if I'm selected there, I guess I could probably start keying something in. Whoops, it thinks I'm in amplitude still, so. Okay, there's my offset. Let's go 0 volts, 0 millivolts. We don't want any offset. So, yeah, just really neat, guys. This blows me away. This is quite the generator, right? Let's go to utility and look at all the settings you have. So you just have 4 channels. You can see channel 3 and 4, there's a few less things than channel 1 and 2, right? Wow, guys, these generators are kind of crazy, huh? There's a lot going on behind the scenes. There's an accuracy thing, right? So you'd imagine the accuracy of, like, say, this beast is better than this little guy. And you'd be right. So there's a thing called parts per million, right? And so, especially with oscillators and things that count on oscillators, like generators, you know, they have 10 megahertz sync inputs, right? So things on your bench, you might all be synced up to this clock so that your counters, all your electronics are all synced up, okay? If you're into like heavy digital or communications type stuff. So Uni-T has been very good at this channel. Thank you, Uni-T. Appreciate it. And so I need to send these back. And so I want to do a quick review and just kind of show you what you get. And there's a huge cost difference too, right? So this little guy, I love this guy because he's so easy to move around the bench, just move where I want him. So I actually use him quite a bit just because of that. Just simple, easy to use. Okay, well, don't want to slide off. He doesn't have anything fancy, just these 2 little rubber feet here, right? So, but yeah, just very easy to use. And I do have this little guy up here, the one up on top, and I had a couple other little small ones, and I think I've been starting to sell a few things, so I've gotten rid of a few generators. I have that Junetech there too, 80 meg. Those generators are actually very useful. They're kind of more, as far as accuracy and all that kind of stuff, I think they fall more in lines with this little guy. So, okay, parts per million. I think this is 100 parts per million. So that essentially is like the equivalent of 0.01% accuracy. And this is after a year. So if you plug this in, you're using it. I think that's after years use that it can drift 100 parts per million. Okay. All right. So the next one, the 1042. Okay. That guy is 2 parts per million. So 2 parts per million. That's like 0.0002%. I mean, that's ridiculous, right? That's pretty darn stable. Now, you know, some labs that are into like really high professional stuff, they need that kind of stuff. So now this guy, it turns out he's the same as that one, okay? But he has some more features, right? So a few more features with this guy. Now this one here, again, even more features, 4 channels as well. But this one here is 1%. It's 1 parts per million. So that's like 0.000 whatever. I can't even, like 3 zeros, 1%. I mean, it is nuts. So this one here is a beast. But the price is stiff too. It's almost $6,000. It's $5,800, $5,900, something like that. I think that's the standard price. I'm going to put the link down below. Okay, guys, I'm an affiliate, you know, with Amazon. So supports the channel for free. Doesn't cost you anything extra. So please use the links down below. I really appreciate it. This guy here, it's a bit cheaper. It's a bit lower cost. Okay. So this one here is like $900, $899. Okay. So, that seems high still, but for all the stuff it does, it's just amazing what you get with these generators. Like this guy here just blows me away, but both of these guys are pretty amazing. Okay. Now the one they gave me up there, that's like $379. Okay. I bought a Signet a while back, and anyway, I sold it to a buddy in Canada, and I hope he likes it. Hope you like it, Jason. But this guy right here, I like it better. So thank you very much, Uni-T, for giving me that. That's great. There's another one that I've been really dying to get my hands on too, and it's a 2000 series. This next series above this one, which I love to have that one, Uni-T. But anyway, that guy and the 2000 series, they are newer generators that have come out. Okay. But now this little guy here, this one's only 108. I mean, only 182. That's still expensive, of course, 182 bucks. But I mean, for nice generators, the price, I mean, 100. And now that's the faster one. There's one that's, I think, 40 meg, which that's 40 meg. So that's still plenty fast for me. It's really all the other features I like more than the high frequencies. The high frequencies elevate the price, you know, because signal integrity, it's not like audio stuff, guys. It starts getting, I mean, you have to be getting very clean signals going through. Okay. So unlike audio stuff that people get all caught up and spend a lot of money on, these guys actually require a little more cost because of that high frequency, that signal integrity, that parts per million stuff, all those things that you want, nice clean signals that are stable. Right now, you saw that as we went from this guy to that one down, you got more and more options of frequencies, especially those modulation things, right? And then the arbitrary waveforms that are built in. I'm kind of wondering if we can download some of those for these two devices that don't have them stored. So the memory, so let me just kind of also talk about those arbitrary waveforms. You can't just take any waveform, like say one that's made for this, and plug it into the lower cost guys, because that waveform, first of all, the waveform on all these scopes, I mean, all these generators, just like on your scope, you know how they went from 8-bit to 12-bit so that they get more resolution. You know, so when they build, say, a sine wave or whatever wave, it's built with like a staircase, and then it's smoothed out, right? But if you can make those stairs really, really small, so they're almost sinusoidal, you know, you have to really zoom in to see those staircases. Well, okay, so let's just talk about that for a minute. This guy here is 14 bits, okay? 14 bits is crazy. Like the new 12-bit scopes, this is 14. So the new 12-bit scopes went up to 4,000 samples, 4,000 steps. This guy is like essentially 4 times more. It's like 16,000. It's a little over 16,000 steps. So that's why with, say, an 8-bit scope or something, it's hard to see those staircases because they're so small in comparison to the resolution of the scopes, you know? So you want to have like an analog signal, like perfectly smooth, right? So you go 14 bits to 16 bits. And then like the rest of these scopes are, I believe they're all 16-bit. Now this guy here, channel 3 and 4, I believe are 14-bit, and channel 1 and 2 are 16-bit. So 16 bits, like another 4 times more resolution. It's like 65,000 steps of little steps. So if you're looking at, say, 1-volt signal, you slice, that's built with a 65,000 little staircases. Crazy, right? So Even 16,000 would be crazy. That takes me to the voltage thing real quick. I believe all of these guys, can go up to 10 volts, and that's in high res, okay, or 20 volts. So I think it's 20 volts peak to peak in high impedance. So when you're going into, like, say, a scope, I'm just reading off the high impedance of the scope, but if you're going into an op amp, some high impedance circuit. Now, if you're going to some low impedance, 50 ohm, 75 ohm, then the voltage drops in half. So it's 20 volts at the lower frequencies. Now, the other thing about all these generators, as the frequency goes up, the voltage drops down, okay? You can imagine the slew rate, you know, how fast you can climb, how many volts per microsecond or whatever that you can climb. If you have to go a lot of volts, then it takes more time to climb. So your frequency goes down. So you know, that's just the way it works, right? So you have to have super fast rise times to be able to go real fast and higher voltages. So it's kind of typical with generators that in high impedance, they'll go up to 20 volts, peak to peak, okay? So that's like 7 volts RMS. But into low impedance, it's like half that, okay? So 50 ohm, 75 ohm, something else that's half that. But high impedance, where you're not having to put out current, it's like 20 volts, okay? So 20 volts or 10 volts. Now, as the frequency changes, like for instance, like on this guy right here, so at 10 megahertz, this guy can do that full frequency, but at 60 meg, that fastest frequency can only do 5, okay? So it drops in half, or 20 volts to 10 in high impedance. So that's this little guy. So just by comparison, the one up there, the next more expensive one, that guy, he can do the full 10 volts or 20 volts and up to 20 meg. So like twice as fast as this guy. So that's another reason why he costs more than this. He can go that higher voltage for twice the frequency. But above 20 meg, then he's limited to about half that volts. Okay, so the volts drop in half. Now, with these two guys, you really have to look at the data sheet, because it breaks down, instead of just like, oh, this frequency, you get higher voltage or lower voltage. With these two, it changes through the frequency range. So it kind of starts to drop, okay? I mean, this guy's a 500 megahertz generator, 500 meg. Where this guy, this one's 80 meg, okay? And then this was 60 and that was 40, right? But 80 meg, okay? So that's pretty high frequency. 500 meg is crazy high. All right, so like your oscilloscope, you have that vertical resolution we talked about, that so many staircases, right? But you also have that Nyquist theory, like, you know, you have to have like at least 2 points to recreate the frequency, right? So really, with scopes, they really shoot for 2.5 times, okay? But anyway, so you need some really, technically, you need a little bit more than 2, even though Nyquist says 2. But there's a caveat in there that you can't start 0, because your 2 points could always be at the 0 line, so you couldn't recreate a signal. So anyway, so 2.5 takes care of that issue. So with these generators, kind of similar. You have to build that signal, right? So with this little guy, he's 60 meg, right? But he can do 200 mega samples per second. So 200 meg samples per second. And that's actually the same as for this guy. He's only 40 megahertz, but same thing, 200 megasamples per second. Where when we go to this guy, he goes to 80 meg, but his samples per second go to 500 megasamples per second. So he's 2.5 times more than these other ones, even though his frequencies only got up a little bit more, like 50% more. So you got a lot more samples, a lot more resolution with this guy. That's why the big price jump. And then we get to this guy, 500 meg. So this one is, like, say, 10 times more than that one, or this one. It's close, roughly 10 times more than either one of these, right? So you go 10 times frequency, it'd be 2 gig. Well, sure enough, it is. It's 2.5 gigasamples per second. So 2.5 gigasamples per second with this guy. Woo! So the vertical resolution and the horizontal resolution is fantastic with this guy. And it's really nice with this guy. And with these two, it's very respectable, right? Like the Junetech, it's going to compete, like I say, more into this range. Even though it's an 80 megahertz, it's as fast as this guy. It's 14 bits, same as these two. And I think it's only 100 megasamples per second, so half as many samples per second as the two Uni-Ts. So just kind of throwing it in there just for a comparison thing, okay? All right, so now back to that arbitrary waveform thing. If you're going to build a waveform, you need all that vertical resolution, the horizontal resolution, but then you need memory, because you're going to build all these lines. You can say, okay, go to this point, go to this point, go out to this time, up to this voltage. And if you build some waveform with all these lines of instruction, you need memory to hold that, right? So this one and that one, they both have 4,000 points. So you can make 4,000 points, which is really nice. That's pretty nice. But now, again, back to the price difference. This guy goes to 32 meg. So 32 meg compared to 4,000. So that's huge. So you can build some elaborate waveforms with a lot of resolution in this, generator. So form factor, all that stuff. Again, and now just talking about form factor, we know the screens on these two are the same, right? They're 4.3 inch screens, where this guy here is an 8-inch screen. And this is a 7-inch screen. You know where I've talked about 8-inch screens being so much nicer than 7? If you can just kind of see the difference between the scope screen here and this, I mean, that extra inch is huge in square inches. It just seems huge. It's just that much bigger, where it's so much easier to read and stuff. I love the 8-inch screens. I think that should be the minimum screen size for a scope, which these are basically in scope packages, right? Now this guy here is a 10.1 inch, so he's huge. Touchscreen. I didn't even know it was touchscreen until I touched it. I was like, whoa, touchscreen. It's funny because I don't see it saying touchscreen, but sure enough, it is, and it works very nice. I like it. I also like the matte finish. It's not real glossy. This one's a little shinier, like this one is. Like, I would say these three are shiny. This one's more of the matte finish like this. It's just a little bit easier, less reflective. All right, so if this was 32 meg, which is huge, right? Then you'd imagine this to be bigger. And it is, 64 meg. So it's twice as much as this. But this guy's huge separation from these two. But between these two, you're already into those serious waveforms. So it's twice as much. Hey, that's still really good, right? Now, you have to look at the data sheet to see the difference between channel 1 and channel 2 has all the bells and whistles, all the deep memory, all the stuff. Channel 3 and 4, they're there. They're very, the capability is awesome, but it is a little bit less than channel 1 and 2, okay? The data sheets are really long, and but yeah, that's what you'll see in the data sheet. All right, so we notice that there's storage, right? So this guy here has 7 gig of storage. That's a lot. So when you look at how much memory those files take and all that stuff, 7 gig, you can save a decent number of files. This guy here, honestly, I'll put it right here if I can find it, but it wasn't obvious to me where the memory depth on this one was. So yeah, sorry about that. I didn't get that. Now that sum thing, where you can sum in the modulation and all that, that's something I haven't played with before, because honestly, I just haven't had a generator that was nice enough to have that option, which I really want. Like the 2000 series has a sum, but it has another thing, which I'm not sure if it's the same or not, but essentially where you can take the two waveforms from channel A and B, let's say channel 1 and 2, and you sum them together. So you can get both those waveforms out on one. So let's say you have a 60 hertz and a 7 kilohertz. You want to do some audio testing. You could sum both those things. It'd come out your output, and you'd have those two frequencies on the same output. So that's the sum. But anyway, that's what the sum will do on these, which I just haven't had a chance to use yet because I haven't had a generator that had that yet. All right, guys. So I hope this was helpful and useful to see, you know, what it is about generators that causes a price difference and why the price can get so high for something like this compared to these. Now, Uni-T, they have, this isn't their best generator for sure. Even in this series, I think this is the middle of the series, I believe. I think there's 3 or 4 in the series, and there's at least one more in the series. It's nicer than this. And yeah, they have, Uni-T does, like, it's amazing their catalog of generators. So they do have a big catalog. So big catalog, scopes, multimeters, but also in generators. So yeah, they're the real deal. But links down below. Thanks a lot, guys. Appreciate you watching. 2 big thumbs up to Uni-T as always. 2 big thumbs up to my Patreons and my YouTube members. Thank you. I appreciate that. And Danny for being a team member. Thanks, guys. You can become a member by clicking the links down below. Super thank you button down there too. And I'm gonna have to package these 2 guys up and send them off, and I got to verify whether or not this was a gift. I think it was, but yeah. And then that one they gave me, and this one they gave me, and that stack of stuff. You know, saw a bunch of YouTube people the guy gifted a bunch of nice stuff from Uni-T. So yeah, they're really nice to the YouTube community. I appreciate that, because that's how we can show you guys some things. And I think having the different levels of generators, I hope that was helpful so you could see, you know, all the differences in them. But man, God, this guy here, wow. Or even this one, I mean, that all those arbitrary waveforms, even though these are all called arbitrary waveform generators and that, I just haven't seen all those cool waveforms before looking at these guys. So that was really fun. I wish I had more time to play with them, but thanks for watching, guys. Again, thanks for watching, and we'll see you next time.